Hello there, this is Chris. Today I'm just going to show a little video here explaining how to create ICMP or ping messages across using automation on top of MacSec in our implementation of MacSec. As we know, there's two implementations of MacSec that we create. So when we have a MacSec scenario under static MacSec, we have kind of two flavors, right? One is the stateless L2, L3. This gives you the ability to send line rate traffic, and the encryption is done at the CPU prior to leaving the FPGAs. So things that you cannot do is like decrypt the packet as we go, right? So because of the nature of this traffic, and then there's another way that we can do as well. It's called L4 L4-7, where we can actually encrypt and decrypt packet on the go because it's at the lowest speed. And you can have an IP stack on top of the static MacSec, right? So that's a difference between the two. So the first implementation here that I'm going to be showing on the left side here is the L2 L3. So for this example here, I'm going to be using 2 ports. In the case that you want to create a one arm scenario, all you have to do is kind of take one of these arms out of the automation and use the information here to create the Icmp packet. So let me run this automation here and go through the code really quick. So the code is going to run here all the way to the capture here. So I'm just going to start off this automation. You're going to see that the connection here is going to create a new configuration, and then I can go over the code while the code is running here. So the first thing that does happen here is create a session and clear the configuration. So you saw I cleared the configuration before going in. And then it picks up the 2 ports right here. That's the implementation for this, picking up the 2 ports and adding to the session. And after that, it creates a static topology 1 on port 1. And it creates Ethernet stack and then a VLAN stack if VLAN ID is added in here, and added the MacSec, the static MacSec on top of it. By default is L2, L3, so we don't have to do anything with that. It's already L2 or 3, so we leave it as this. I'm disabling the gratuitous ARP that gets sent out to make the capture a little bit more clean. And after that, I configured the other side of this topology here, and then I create traffic. I'm actually creating IPv4 type of traffic, where I'm sending from one side to the other. And over here is the rate. I established the rates, and then after I have my IPv4 traffic item here, I add the Icmp code on top of it. So I'm kind of simulating so I'm creating Icmp reply message that I'm sending to the other side. But there is on this case here, I'm using so this is the scenario that got created. On this case here, I do not have a state machine running on my port 2, so I'm not going to have a response. But what this automation gives me is the ability to, one, create an SMP packet request that's going to be sent out of this port number 1 to port number 2. But I'm not going to be able to see a reply. All I can do in my case here, since I don't have a real dot, is just to capture the packets on port 2 and see that they are in fact encrypted ICMP type of traffic that's come in. So if I had a real DOT, that should be able to reply to that. But in my case here, all I'm going to do is just send packet encrypted to the other side, and when it gets to the other side, I'm going to decrypt it using Wireshark and make sure that the Icmp message is correct in there. So as far as the test itself, the only thing I'm going to start here is enabling, disabling capture. So software means control plane, and hardware is the data plane. So I'm enabling the data plane. I'm starting the capture, and then I'm going to be sending 10 packets. It's 1 packet per second, and then I'm going to wait for that, and then I'm going to stop capture. And when we stop capture, we can go into the code here and take a look at what kind of packets got created. I'm expecting that I create an Icmp packet with a payload of 1280, right? So at this point here in the code, those are going to stop capture, and I'm going to stop at this point for now. So at this point, I can just look at how many packets got captured on the data plane, and I see that 10 packets got captured on the data plane. Now I can go back into my configuration here and look at my data plane, the 10 packets that got captured, and I can take a look. So I'm on port number 2, so this is packets that I received, right? So this is the packets that I received. So it's from port 1 to port 2, and the Icmp. So it is a packet that is encrypted. So you can only see the encryption after you dissect the payload here. You can see there was Ethernet, IP, and then an Icmp packet in here. So and the one thing that I see here that's missing right now is the VLAN, right? So there was one portion here that the encryption is not taken care of. It's the VLAN. So I'll take a look at that. But in synthesis, that's what it's doing here. At this point, I'll jump to the other demo, and then we can conclude. So for the other demo, I'm actually going to be using a layer 4 through 7 configuration that is already up and running. So for that, I'm going to load the configuration. So give me 1 second here. I can locate the configuration. On this configuration here is pretty much the same configuration I used for the automation piece, but this time around, what I'm going to do, I'm going to instead of cleaning up the configuration, I'm going to log in. The automation will log into a configuration that is already running. So as soon as those ports come up, so as you can see here, the difference that I have an IP layer on top, and since I do have an IP layer on top of it here, I can simply use the commands for sending a ping, which send a ping like this on the GUI. I'm going to be doing the same thing on the automation piece. So I'm going to start protocols here and let the stacks come up, and then as soon as the stacks come up, I'll start the automation. So the automation is it's going to run, and it's going to one here is going to create a session with an existing session. It's not going to clear the config, so it's going to use the configuration that's up. After that, it will grab the ports, find information on the ports, and then grab the static IP here. So it's looking for this stack here, so it can execute the test. So after it gets the IP header or the IP stack, this is the code for that. It's going to clear the stats, and it's going to send ping with a count and a payload. So the ping is going to be the destination, it's going to be the other side. Ping count 10 of them, the rate is 1 per second, and the payload is 1280. Alright, so, and then it's just going to sleep, and then it's going to go in and count the packets based on my global protocol statistics. It's going to look at the ports that I sent the ping, and I'm going to say ping request and ping reply, and then I'm just going to compare those two. So this is what this automation here does. And so let me I can just simply run this automation. I don't have to do a debugger. And so as you can see here, the automation is going to use the session that is already up at this point here. We're just going to have to wait a little bit and you see things happening. So it's going to send ping, and then we can look at my my global protocol statistics, because that's the table that I'm actually looking at. So it's global protocol statistics here. You can see here the control packets are 12, and the ping send and received is 10. So 10 pings got sent and received on top of a MacSec layer, and that is really the test. It's right here. So test pass, all pings sent were received, I expected 10, and then I'm just printing out the stats for the global. So that's pretty much all this little automation here does. Both of this code can be you can get access to in GitHub. So it's in GitHub right here under my name, under IX Network Samples. So if you have any questions, feel free to reach out to me and we can go from there. Thanks. Bye.